All right, so welcome everyone to the Atlantic Geoscience Society Traveling Speaker Series. So my name is Lynn Dafo. I'm a member of the Society, and I will be your host for this public geoscience talk. And I'll just mention that this is organized by our Traveling Speaker Series Committee, which includes Sheila Waters, Katrina Russell, Matt Stimson, and myself, and we are all here today. And thanks to Dave Lentz for hosting on Zoom for us. And if you do have any feedback, just say that normally we've been doing this as an in-person event. However, over the last few years, we've switched to virtual format. So if you do have any feedback, feel free to use the chat if you think you like the virtual, or if you would prefer in person. It'd be great to have feedback. And as Dave mentioned, he's recording the presentation today, but we will end the recording before the question period. So you don't need to feel that you'd like to turn your camera on at the end and ask questions. You will not be recorded. And yeah, so please feel free to use the chat during the presentation to pose questions, and we will address those at the end. Or if you prefer, you can turn on your camera and microphone and also ask them that way at the end of the presentation as well. So I'd now like to introduce our speaker, Dr. Rob Rayside. He's Professor Emeritus at the Department of Earth and Environmental Science at Acadia University. So Dr. Rayside ventured from Scotland to Canada in the 1970s and holds degrees from Aberdeen, Queen's, and Calgary. He's taught at Acadia University since 1982 in courses ranging from mineralogy and petrology to structural geology and tectonics. That's quite the range. Early in his career at Acadia, he admitted that he had taken a course in climatology as an undergraduate student. And upon returning from a sabbatical leave, to discover that he had been assigned to develop a new course in atmosphere, weather, and climate, which he's now taught for 30 years as a requirement for the environmental science program and elective for the geology program at Acadia. So he maintains an interest in how weather and climate have played a role in our history. And he's going to be presenting for us Has Climate Change-Driven Human History? Lessons from the Past for a Future Climate. So take it away, Rob. And then just again ask if everyone can mute themselves for now until the presentation is over. That would be great. Thank you.
Thank you very much, Lynn. And it's a pleasure to have everyone join us this evening for the Traveling Speaker Series. As a traveling speaker, I anticipated that I would probably be giving an address to people who were coming from a wide variety of backgrounds. So this is not going to be a talk that's heavy into geoscience, and it's certainly not going to be a talk that I got a whole lot of depth in. As Lynn just pointed out, I teach a course as an element for the environmental science students, but this particular presentation was actually developed for another geology course in quaternary geoscience. It was a fill-in lecture, and it ran far too long. So I've shortened it a little bit for tonight, and I hope that we can get through it in 45 minutes. Has climate change driven human history? And we're going to look at some lessons from the past for a future climate. Where do you go when you want to find out information to teach a class on climate change and human history? Well, obviously, the first place you go is the library. And the library for climate change is the ice core. When we start looking at the details of the ice cores in Greenland, in Antarctica, and in various places of mountaintops around the world, we can drill into these ice cores to get information, detailed information about the last many thousands of years. So here you see someone drilling in the ice core, and the ice core is over on the right here. And individual layers of ice here represent annual layers of snowfall, and within the snow is, when it gets compacted, there are samples of the atmosphere. And so we can measure those samples of the atmosphere from days gone by. We can count the layers back, going back as much as 800,000 years in the East Antarctic. down through 3 kilometers of ice. That takes us back through the last 2 ice advances and the last 2 ice retreats. So it takes us well back in time and well back into the early days of human history. I'm going to start this presentation by looking at the earliest days of human history, but I'm going to bring it right up to the 20th century, 21st century, by the time we've finished. So as we look at that ice core, that library of information, what do we find in it? As I mentioned, we can figure out the amount of carbon dioxide, which is shown here by the red line, going back in time from today on the right, back to this one's getting close to 500,000 years. It's not quite 800,000. And in blue, you can see the temperature variations. These are determined largely from the isotopic data from the oxygen gases in the bubbles in the ice core. And you'll see that climate changes. As we go back in time, we've got warm periods, we have cold periods. These are matched by higher carbon dioxide concentrations and lower carbon dioxide concentrations. And I want you to look at the far right here. You'll see there's a period of a somewhat more stable climate, maybe only about 10,000 years. We'll look at that in a bit more detail in a moment. But what we'd first have to address is, how did our earliest ancestors, those early hominins, survive these huge fluctuations? As we deal with a massive fluctuation in temperature today, it would be instructive to know how our ancestors survived situations that were as much as 8 degrees colder than normal, and perhaps even a couple of degrees warmer than the more recent average. That previous graph took you back nearly half a million years. This graph takes you back 18,000 years to the end of the last ice advance, when Nova Scotia and New Brunswick were buried under kilometers of ice. As the temperature warmed between 18,000 and 11,000 years ago, ice melted, and we moved into a period of remarkable stability. If we put this into a historical term, you can see the period of the late Stone Age at the beginning of this period of stability, into the Bronze Age, Iron Age, and of course we'll have to look at the Vikings at some point through tonight's presentation. So this period of remarkable stability is when much of our history developed. However, we can take history back about 4,000 years. Beyond that, written records are rather few or difficult to interpret, but we can see that we have a situation going back to about 10 or 11,000 years ago, where things were relatively stable, but there's a much colder period before that. And our earliest ancestors must have survived even that cold period. The last of the Australopithecus ancestors, the Afarensis lucy, died. That particular genus, Australopithecus, died out about 1.8 million years ago, so much longer than the longest ice core. And the Homo erectus, which is some of our our earliest ancestors in the Homo genus, they appeared about 2 million years ago, maybe a little bit more than that. Homo had a bigger brain, more complex tools, was probably a bit more prone to wander, and perhaps that wandering coincided with drying events in the East African climate. These early ancestors primarily are associated with the Rift Valley areas of Eastern Africa, which at some points in the last 2 million years would have been rainforest, other points dried out to become savanna, like the scene at the bottom of the slide here. So our early ancestors had to negotiate these changes in climate that produced changes in vegetation as well. There are some workers who think that it's those dry periods that forced our early ancestors to move, but it's not all cut and dried. When we look at the Indian Ocean sediment cores that are drilled from the Indian Ocean just off the east coast of Africa, we can track the variations in precipitation. If we see particularly dusty layers, that probably represents dry climate. If we see more organic material, that represents a more humid climate. And during the dry times, we see that on land, the distribution of our hominin remains increased significantly. And the chemistry of them indicates that they switched over from just a foraging lifestyle to foraging and hunting, so vegetarian to omnivorous lifestyle during the dry period. And so the thought there is that drought produced a stress, which also produced an evolutionary pressure that started our ancestors moving. On the other hand, there are also visible links between wet periods and the diversity of the Homo and Australopithecines genera. This graph from Schultz and others in 2013 I found quite interesting here. It plots through time, so 5. So as we look at the line here, the yellow line, which indicates some of our earlier ancestors with a smaller cranial capacity, moving up to Homo erectus, moving up to the Heidelbergensis, and then up to the modern humans, Homo sapiens, you can see the increases. And each of these increases does appear to coincide, the beginning of them, with a wet period. So this particular paper makes the argument that the wet periods were the ones that induced the jumps in cranial capacity, promoted the most rapid Homo evolution.
Whole apartment hills out.
So moving on from the earliest members of our species, let's move up to much more recent times. As we move up to the last 10,000 years, so into that period of climatic stability that I referred to earlier on, we begin to see evidence of much wildlife in what we would now call the Central Sahara. Here in Eastern Algeria, we see some very famous cave paintings with things that look like the ibex. I'm not sure what this animal is here, but giraffes, obviously, and other bovine species in the cave paintings. In central Libya, there are etchings of elephants that were roaming the area, and particularly in southwest Egypt, we have this location referred to as the Cave of the Swimmers. Here you can see people in a swimming posture. These are today deep Saharan locations, but they represent that Mesolithic to Neolithic time period up to about 4,000 years ago, with many animal species that certainly do not belong in the Sahara Desert today. In fact, if we look at the conditions in the Sahara Desert today, the present vegetation indicates that all of these areas are in what we would refer to as extreme desert. We can tell from deposits, particularly in some of the lake basins, like around Lake Chad here, that 5,000 years ago, this would have been a semi-desert situation, but 8,000 years ago, a grassland. And that would have supported, of course, the animals that we see there, the buffalo, rhinoceros, giraffe, and so on. So there is very good evidence that the grassland vegetation of North Africa was prevalent across much of an area today as the Sahara Desert. Turning it into a desert is often described as sudden or rapid or brutal, but it really wasn't immediate. The cause of this is well known. It's astronomical. It's all driven by the Milankovitch cycling with the way the Earth circles in its orbit around the sun, and we move into a period which is past the peak of maximum insolation, maximum incoming solar radiation, and we end up with a drying of our modern desert latitudes. That drying happened in several stages between about 7,000 and 4,000 years ago, and it would have pushed the population, the human populations, out to the edges of the desert. So I think we have very clear evidence that, that human migration, at least, was being driven by this ongoing desertification process. So that outmigration from the Sahara resulted in people looking for water. Concentrations in the Nile Basin or in the Niger River Basin or further to the south in the Congo. Looking at the Nile Basin, we have the best record in this area. This is the Nile River in Egypt, and we see evidence of farming beginning to kick in the valley of the River Nile. Settlement in this area began around 7,000 before present, and agriculture began about 5,500 years ago, which is coincident with the first drying of the Sahara. By the time we get to the Old Kingdom of Egypt, about 4,000 years ago, we're into the main drying of the Sahara Desert, and any populations that were left there were very much subsistence populations. The people who moved out, however, are forced into this relatively narrow area, and began to develop agriculture. This is where we first see the development of farming. And so the question we must pose is, was the adoption of agriculture being driven by that climate change, by that drying of the Sahara? Let's take that one step further. If we go a little bit farther afield, we see that the drying extended out into Asia as well. Probably the oldest civilization that we can recognize is that of the Mesopotamian region today in southern Iraq. This is a Sumerian civilization around about 6,000 years ago. This is a dry region today, very dry and hot today, but even 6,000 years ago, it would have been prone to drying out except for the short seasonal spring rains. Now, this is the valley of the Tigris and Euphrates rivers. We've heard lots about them over the last decade or so. But it's an area which is fertile, but doesn't have a lot of natural resources. There's no stone, there's no wood, not a lot of forest vegetation in the valleys themselves. It's fertile, but it's dry. So in order to sustain agriculture, irrigation becomes necessary. And when you start getting into irrigation, you start getting into water rights and people jockeying for water against their neighbors. That also, of course, builds wealth for some, poverty for others. And where you see wealth, you see the potential for invasion from the surrounding tribes, perhaps some of these mountain peoples in what would be referred to as Iran today, and the possibility for external conflict. So now I would like to pose the question, was the invention of war or invasion caused by climate change, dealing with these early farmers in the Sumerian kingdom? Taking that into bringing that up closer to the present, that in order to survive in a situation like that, leadership is necessary. And when you have leadership, then you start getting an organized civilization with things like writing, trade, taxes, and large buildings, whether the temples or granaries, doesn't matter at this point in time. But if we have strong leadership being developed, we can't guarantee that leadership will survive through all times. If we have a period of weaker leadership, invasion is inevitable. And if there's further drying, then there's going to be out-migration. And if we begin to see migration around what's referred to as the Fertile Crescent into northern Iraq, southern Turkey, and down into Syria and modern-day Levant. And this is famously recorded in Abraham's wanderings in the Bible, where we see that Terah, who was Abram's father, Abram was called Abram at that time, and his son, and they went forth together from Ur of the Chaldees, which is located somewhere in southern Mesopotamia, and moving up into over towards Canaan, but they stopped in Haran, which is in northern Iraq or southern Turkey, and settled there for a long period before continuing the journey down into Syria and Canaan. These wanderings then are likely climate induced because of the drying out of the southern regions of Mesopotamia. And in fact, the Sumer region was never really settled again after this period until population pressure forced people back down in there. This would be the location of Basra, for example, in Iraq today, when population pressure in the 20th century forced settlement. So that strong leadership and the establishment of a society perhaps was the driver of a priestly class which preserved the stories and legends of the earlier times. When we start talking about the stories and legends, we always encounter the flood legends and sea level rise stories. I'm not going to deal with this extensively tonight, but that priestly class became the depository for these origins, these legends of origins, and many of them do involve a flood that destroyed an earlier culture. This is referred to as the diluvial hypothesis by the archaeologists. And the question is, how would you remove a civilization quickly? Flooding is one way to do that, but there are about half a dozen different ways that a civilization could be removed. Flood, fire, volcano, perhaps more isolated, invasion, disease, we're all familiar with that now. And fortunately, we've never really had to deal with a bolide impact yet. And it sounds like NASA is on track to keep that as free from that as well. But flood is one of the one that's most common, and fire, and as we'll see later, actually drought is another one that we're going to have to deal with. If we look at these flood legends, there have been a lot of people have tried to connect them to sea level rise. So I want to look briefly at what truths there are to these flood legends. We do see sea level rise from about 20,000 years ago up to about 10,000 years ago, and it comes up in a number of steps. It's not quite steady. These are referred to as the meltwater pulses that are associated with outbursts from the continental ice melt lakes, North America being one of the sources of these ice melt lakes. And it's possible that these rapid increases in sea level rise are driven by some of these meltwater pulses, but none of them are instantaneous enough to represent a flood. These are happening over hundreds and thousands of years, several hundreds of years anyway. And so although they may actually change coastlines, the position of the coastline, they're not going to represent an instantaneous flood. This whole business about the flooding is really very controversial, and it has not only in the Middle East, but also in the Bering land bridge. Part of the controversy is because the amount of evidence is really very minimal. There's not a lot preserved. You have to remember that during the Wisconsin ice advance, sea level was lower, and so any coastal locations that might have been settled are now drowned. And so we're not going to see where people were living near the coastline. We end up looking at only the inland sites. We do see population of the New World, however, coming in somewhere between 10 and 20,000 years ago. The very oldest confirmed sites are actually some of the further south ones down here in Chile, although there are some records in Sao Paulo state in Brazil that might be back to 20 to 30,000 years old as well. But that seems to be the populating period of the New World after 30,000 years ago, much later than the outmigration from East Africa. When we look at the peopling of the Americas, one of the primary lines of evidence are the tools that were left behind. And one of the most famous ones is the Clovis culture after a town in New Mexico. In the Clovis culture, there are these very characteristic spearheads that were formed, and it's the finding of these spearheads that we use to document that particular group of people. They lasted about 1,000 years or so. By 11,900 years ago, they seemed to disappear, and it's not clear exactly why they disappeared. Some hypotheses bring the Younger Dryas into it, where we have a major meltwater pulse, which resulted in a temporary cooling during an ice retreat event. Others bring in an airburst comet coming in here. This is that famous structure down in the south of the Annapolis Valley in Nova Scotia by Bloody Creek that some of the people here at Acadia discovered about 20 years ago from air photo imagery, and have speculated in whether it might be a bolide impact of some sort. And we were assaulted by people at the AGU conference a few years ago, indicating that is it possible this might be one of the records of that 11,900 cooling event. We don't know about that. Another possibility is that the people themselves were their own worst enemy, that the global warming resulted from technological advances that allowed the hunting of the large mammals. And those large mammals were responsible for maintaining a tundra-type landscape over much of North America. If the large mammals, the mammoth, the camel, the bison, were largely exterminated from those areas, they remove the herds, forest begins to take over, the landscape darkens, the albedo, the reflectivity of the surface increases, which gives further warming, with perhaps 1/5 of a degree or so in 500 to 1,000 years. Doesn't sound like a lot compared to what we're living with today, but it may have been enough to allow the continued growth of taiga forest as opposed to tundra in these latitudes. And that would not suit the style of hunting that had been developed. If we look at the New World peoples and bring it up to the more modern day, taking us into what would be the European Middle Ages, we begin to see the effect of droughts, and that is often invoked as the terminator of a civilization. And this is particularly the case anywhere that we're dealing with a semi-arid location. Drought is always going to be a threat there. Civilizations can expand during humid periods, but when we have dry periods or seasonally dry, long seasonal dry periods, then we see them dying off. And a particularly famous example is the Anasazi people of Arizona. Here you see some of these cave dwellings of the Anasazi. These are not the Anasazi. This is a tour group that's visiting the cave dwellings down here. But the tree rings and the pollen records from that time showed clear evidence of drought. Was that drought caused by the depletion of the forest resources around about it and reduction of humidity? Is it self-created by the people themselves, or is it a natural case of drying out? That's not something that is easily addressed. We see the same thing happening with the early Mayan civilizations further south in Central America. In the Mayan civilization, the early Mayan civilization, the population may have exceeded 15 million people. And it's often quoted that it suddenly disappeared, but it didn't really disappear. The people were still there. It's the centralization of the population that disappeared and the growth of the cities. The pollen evidence from places like the Yucatan indicate that there was a transition from more humid climate species to more semi-arid species. And that may have been caused by deforestation. And deforestation is probably human-induced. With 20 million people, 20 million mouths to feed, the land had to be cleared for agriculture. The wood would be used for cooking and for all that construction that we see with all those pyramids in the Mayan civilization. Just in order to make the lime for that manufacture would require a huge amount of fuel as well. So that it was likely that much forest clearing went on, which may have been enough to change the climate locally. Computer modeling has been done of deforestation, of the effect of that deforestation on climate. As the forests are cut down, the reflectivity, the albedo increases, the humidity gets lower as there's less recycling of water. And some of the modeling that's been done indicates that that deforestation alone could account for up to 60% of the drying, meaning that there had to be some other drying methods going on in the background. This was coincident, however, with the maximum density of population. And in the later Mayan cities in the northern Yucatan, we see enormous underground reservoirs being constructed as well, perhaps an indicator that they were already experiencing the beginning of these drought situations. So the inland cities declined, agriculture ceased, and it may have been brought on by the deforestation of the society. They're not the only society that demonstrates deforestation. We see that in Cambodia, in Pakistan, in Greece, in the Levant. We see civilizations which have outgrown their capacity to survive, particularly in wooded locations. Well, I mentioned earlier that we have to talk about Vikings, and that brings us up to the medieval warm period and the Little Ice Age. These are not strictly defined periods, and they're definitely focused in the North Atlantic. They're much more prominent in the North Atlantic, and there's still much argument as to whether or not they are global. The medieval warm period, somewhere in the region between 950 and 1250 in the Common Era, can be identified based on botanical records. And this graph here shows a number of proxies which show from 2000 years ago, so this would be 0 Common Era up to 2000 in the Common Era, so the modern day 2020 up around about here. These proxies show ways of determining temperature, average temperatures across the North Atlantic at that time period. Some of them are tree rings, some of them are pollen species and so on. Some of them are instrumental records. When we get into this black line, that's what we're looking at there. But overall, although there's a bit of disparity among these data, you see that there's a warmer period around about 1,000 years ago with a long period of cooling up to about 200 years ago, and then the modern warming event. So that's what we're looking at for the medieval warm period and the Little Ice Age as far as time frame is concerned. It is primarily a mid-latitude phenomenon and is clearly a warmer North Atlantic phenomenon, and it's associated with those Viking travels. So if we take a look at the Vikings, why did they want to migrate in the first place? Well, the fact is that that medieval warm period induced good growing conditions in Scandinavia, which is, is fairly far north, so reasonably prone to marginal agriculture. But as the climate warmed, the agriculture succeeded and the population outgrew the availability of land. If you run out of land, then you start moving into internal strife, and one of the solutions is emigration. And those people from Scandinavia moved out into the various locations, the purple-colored areas along the British Isles, into Normandy, the Norse or the Normans of Normandy, Iceland, and of course, famously over to Greenland and Lands of Meadows. The Western lands were known, Iceland and the Faroes were known, and some of the explorers made it further west than that. But that all good things come to an end with as the Little Ice Age comes on and the medieval warm period begins to wane. And the settlements in the north, in Greenland, and in the west were eventually abandoned. Lands of Meadows probably not in existence for very long. And what populations were left in Greenland became quite isolated. And from the chemical record of the bones and teeth of skeletons that have been found in Greenland, recognizing that the last population survived only on fish, there was no longer any agriculture happening. In Iceland, population estimates indicate a continual decline in population from the peak of the medieval warm period to the depths of the Little Ice Age. And the grain crops are limited to barley as the only grain that would survive the shorter summers of that cooler period. That cooling started then around 1100, continued to about 1800, and it coincided with increased storminess. This woodcut shows a stormy situation in the Netherlands, but take a look at the graph here, which shows the number of reported sea floods per century around the shorelines of the North Sea and the English Channel. And this goes from, obviously the records are limited in the first 1,000 years, but if we look from 1,000 years ago to almost the modern day, we see a peak of storminess with major floods in the first part of this period. And the speculation has told us that this may be a change in the shape of the jet stream, something that we're watching very carefully these days with our global warming situation. But as the jet stream becomes more meridional, so more into a north-south motion with big loops in the jet stream, it entrenches storm systems for longer periods and makes for more intense winter storms that last longer. And this produced devastating flooding around the North Sea, the low-lying shoreline of the Netherlands, northern Germany, and eastern England. 4 times in the 1200s, records of over 100,000 people that may have succumbed to that coastal flooding, and then repeatedly through the 15th and 16th century as well. And then into the 17th and 18th centuries with the cold weather that produced all the famous images of people skating in the canals of Amsterdam. So how did the Little Ice Age affect agriculture? If we go back to the period of the Domesday Book in the 11th century, we see records of grape growing in England. That died out. Whether that was because of climate or because of changes in legislature can be argued, but it's clear that the growing season was shortened by as much as 15 to 20%, and the range of crops was reduced. This graph shows the price of rye indexed to show its modern value in Germany from the 1500s up to the 1800s. And you can see there's a gradual increase. Now, there are a lot of big spikes. These big spikes are individual events. Some of them are identified here. The eruption of Tambora and the year without a summer produced one of the biggest of these spikes in the price of rye. But overall, if taking those out, there is still a gradual increase as we go through time. So it looks like the value of the product that was being produced was increasing through this 500-year period. We also see a change in forest growth in Central Europe, changing from the beech dominant to oak dominant to pine bearing, indicating cooler and perhaps even drier conditions as well. One of the most notorious aspects of the agriculture and in Little Ice Age concerns the outbreak of a disease referred to as St. Anthony's fire. You can see the details of the disease there, but it's often referred to today as ergotism, and it's produced from the fungal infections in rye, which was an important crop in the northern and central Europe. That fungal infection of rye resulted in this situation in the people who ate it, and it was quite widespread in Europe up to the 1700s. And it's promoted by the cool, damp storage conditions that would have been prevalent in a somewhat colder landscape. If we take a look at the economics through the Little Ice Age, we see evidence of drought and floods. This was not a great time to be around. Food prices spiked many times. There was severe famine in Europe at various points in time. There's lots of record of damage to harbors, wharfs, and bridges from major storms. We see the movement of fisheries southwards with cooler temperatures, and in the alpine environments, the advance of glaciers as well. This led to a downturn in agriculture, and as agriculture dropped off, people migrated into the growing urban environments and the development of industry and trade. That move from rural to urban, of course, would incite various social problems, with civil unrest becoming more prevalent. And let's take us up to 1789 and the French Revolution. Again, there's a climatic hint in the background here. The winter, the year before, 1787-88, was particularly severe in northern France, but more importantly, it was followed by a very, very dry spring, which resulted in very poor crop germination. And grain prices spiked, leading to the bread riots in 1789. And of course, that famous statement that probably didn't come from Marie Antoinette, but wherever it came from, it's associated with the French Revolution. If they have no bread, let them eat cake. So what did it? What was the cause of the Little Ice Age? It's been attributed to various factors. Solar output is going to be one of them. Orbital cycles is certainly in the background, although maybe not fast enough to give us that much temperature decline. Volcanic activity may have initiated it, but volcanoes are pretty short-lived. Ocean current changes are always there in the background as well. The solar output one is particularly interesting, and many of you will probably have seen this graph before that represents the sunspot observations back through time. And although we have a regular 11-year sunspot cycle over the last 270 years or so, in the period referred to as the Maunder minimum, sunspots became relatively few, and the cyclicity of the sunspot cycle was lost for about 50 years. When the sun is more active, then the sunspots are more visible, they're more prevalent, and that provides more energy to the Earth. So this Maunder minimum with fewer sunspots would have represented a slight cooling of the sun, perhaps in the order of 0.5 to 1% cooling of the sun over a 50-year period, which may be enough to maintain the cooling of the Little Ice Age. So that gives you a bit of an idea of some of the features in history. A lot of it is very speculative. A lot of it seems to hint to climate change, or climate control at least, in the big scale and on the small scale, like the French Revolution in a 1-year period. I want to switch our gears a little bit now to look at what I refer to as future history. The agriculture, the settlement patterns, religions, the history all hint at that climate control. And as we look at the expanding population, we begin to see the resource base becoming an issue. And of course, our population has never expanded like it has in the last 100 years. So our resource base is now becoming extremely stretched. When we talk about resource base, we have to deal with space. We have to deal with availability of arable land. We have to deal with the mineable materials. We have to deal with the availability of wealth, and most importantly, with water. Now, these scenes that I show below you here are from Central California, 2011 and 2014. In 2011, a time of water plenty, the reservoir was filled, and the boaters had freedom of the waterways. 3 years later, it had evaporated or drained down significantly. This is a reservoir, so some of the drawdown is going to be for power production and water and irrigation purposes. But many lakes in California saw this drawdown. Following 2014, we had a regeneration, but now we're back into yet another dry period in California. I just want to emphasize that these wet and dry periods do come and go. That drought is quite intermittent in California. It can be seasonal, it can be multi-year. And you may remember about 4 or 5 years ago, there was a considerable concern about the Oroville Dam in California, where the overflow was in use because of high water levels behind the dam, and the sluiceway broke, and there was concern that this was going to wash out the dam. It never did. But what caused this particular fill up of the lake? This was only a few years after that very dry period I showed you in the previous slide. One of the principal drivers of it is the Pineapple Express. This is a particularly wet river of air, almost the thickness of the entire troposphere, that sources out over the Hawaiian Islands in the southwest of the graphic here and forces itself eastwards. For this particular Pineapple Express, it was blasting full force on the west coast of California. Sometimes it's farther north, even as far north as British Columbia. But this was the one that filled the lakes. I suspect the Californians would be very happy if we had another Pineapple Express this coming winter, because they are in an extreme drought situation today. Looking at future history, however, if we go back about 10 years ago, we were very much in the news was the Syrian conflicts. And again, it's not entirely due to drought. There are political reasonings behind it and all kinds of international deliberations going on. But northern Syria, which is the area of Syria that is most densely populated, had moved into an exceptional drought condition in April 2014. That Syrian drought that resulted in the need for people to leave their farmland because it was not producing and move into the cities like Aleppo and Damascus and so on. And today we see the same thing happening today in the US. So we see population changes as a result of it. The last 3 or 4 years, we have had a significant drought in the West. This is the current October drought monitor of the US. And you can see that across the high plains and in the desert states, and especially in the Great Valley of California that supplies so much of our winter vegetables, this area here is in an extreme drought situation at the moment, and there is need for drought. Now, this is an area of a Mediterranean climate. Mediterranean climate should be dry at this point in the year, but this is extreme even for this point in the year. This graphic projects us forward into the end of the 21st century. And I think it's a particularly sobering graphic because it shows where the predictions of future drought are likely to be. And we can see that the sorts of locations where future drought is likely to be extreme are places of considerable population pressure, these Mediterranean climates, which are very much prone to, well, they have a summer dry period with winter rains. But if those winter rains shift a little bit northward into the Central Europe rather than Southern Europe, then this area is going to be extremely dry. Likewise in California, which is what we see in the left of the screen, or in the Mediterranean type climates of Southern Australia, South Africa, and South America. So any of these places where the seasonal shifts of the wind belts produce this extended dry spring, summer, fall period with only seasonal winter rains, if these winter rains are reduced to any extent, then we have the potential for significant population stress in these locations. So is history climate controlled? I like to think of climate as a control knob in human affairs. If we deal with scales from the 100,000-year scale for our early hominin ancestors to a 1-year drought, we see that a climate change in the background. We've had that remarkable stability of climates in the last 10,000 years ago, which has allowed the development of civilization and the development of agriculture, war, religion, all possibly tied to climate changes. But drought seems to be one of the most significant driving forces. Here is the July 2022 world temperature average, temperature values, and you can recognize these graphs are all over the place nowadays. There's very little blue on them. The blue that we see across the Pacific is the developing La Nina, that we're moving into a 3rd year of La Nina situations, but it's only a little bit cooler than average. Whereas we see large areas of the world that are much warmer and even record warmer than average, famously in China this particular year. And so our temperature is rising, and is continuing to rise, and we don't see any immediate stop to it. Homo sapiens as a whole has responded by moving rather than adapting, but the space to move is soberingly scarce now, and we will have to deal with that. So let me finish up by going back to one of the first slides I showed you. I showed you that period of remarkable stability, that 10,000, 11,000 years of stability. And I showed you the temperature variation through here. That temperature variation is tied to a variation in carbon dioxide in the atmosphere, and the carbon dioxide in the atmosphere is a greenhouse gas, and as we know, it is rising drastically. Temperature is lagging behind it a little bit at the moment, but it will surely catch up, and I think you can see that our period of remarkable stability appears to be coming to an end. So I think that should give us all a good idea that it behooves us well to do our utmost to maintain as low a level of carbon dioxide in the atmosphere as possible. That concludes my presentation here with that sobering aspect of the last 50 years, really, the last 25 years, where we see the temperature rising. And I'll leave it there and turn it back over to Lynn if you want to field any questions. I'd be happy to take them.
Thank you very much, Rob. That was a wonderful presentation. And we had a good audience. I'm just going to stop the recording here, and then we can move on